Hello again. Okay, so we are back with our wonderful foldable, and today we'll be doing 4.3, angle, angle, side, and angle, side, angle. So let's start with angle, angle, side. And we'll flip this open. And what it says is, if two angles and the non-included, maybe I'll zoom in a little bit here. If two angles and the non-included, so not between the two angles this time, of one triangle are congruent to two angles and the corresponding non-included side of another triangle, then the triangles are congruent. So let's look here. I'll just move this one over a tiny bit. All right, so in these triangles, ABC and DEF, we have side AC marked as congruent to side DE. Okay, and then we have angle A congruent to angle D. Okay, well, that works. And then we have angle B marked congruent to angle F. So, because the corresponding angles, right, two lines and one line, are congruent to the corresponding sides, and this is not the included side, right? It's not between the two congruent angles. We can say that these triangles, ABC and DFE, are congruent because of angle, angle, side. All right, and it's really important that you write them in the same order. So I started with A, which has one line, and then I moved to B, which has two lines, and then I went to C, the angle with no lines. That means when I write the congruency statement, I need to start with the same angles in the same order, the corresponding angles. So angle D with one line, angle F with one line, and angle E with one line, no lines. It's really important. If you want to say that they're congruent, they need to be identified in the same order. Okay, that is angle, angle, side. Let's move down to angle, side, angle. Okay, what it says is if two angles and the included side this time of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. So, notice here we have an angle, and then in between it is a side and another angle. So this means that this is the included side. When it's the included side, you would use angle, side, angle. When it's the non-included side, you would use angle, angle, side. So, angle A is congruent to angle D. They both are marked with one line to show that they're congruent. Side AB is congruent to side DF. All right, they're both marked with one line, the sides, to show that they're congruent. And then angle B is congruent to angle angle F. They're both marked with two arcs to show that they're congruent. So we could say that triangle ABC is congruent to triangle DFE. Again, don't forget the order is super important. A is marked with one arc, so it has to be identified in the same order as angle D with one arc. The side, there's only one side to think about this time, so B, and that corresponds, or AB, and that corresponds to DF. And then we have the same type of thing with angle C. It has no markings, and angle E has no markings. So that's the order we come up with. Angle, side, angle, and corresponding order. All right, let's look at a proof that uses this type of congruent statement. Okay, so we are given angle M right here. It's marked with one pink arc, is congruent to angle K, marked with one pink arc. And then we're going to tell you that WM, this line right here, is congruent to RK, this line right here. Okay, they want us to prove that triangle WMR, what I highlighted in green, is congruent to triangle RKW, what I highlighted in pink. So of course I'm going to start with number 1, and this time I identify both of my givens in the first statement. So my reason is given. All right, and then we move down to something a little bit more tricky. I'm going to say angle MWR, which I identified right here with 2 green arcs, is congruent to angle KRW, which I again identified with 2 green marks. And why is that? Well, if you look closely, these are the 2 lines that we marked parallel, right? Here and here. So that line with the pink and the green going across it is actually kind of a transversal, and it creates an angle relationship here and here. So I could say that those angles are congruent because they are alternate interior angles. Alrighty, well then I'm going to say that WR is congruent to WR, and hopefully you remember that's like your reflection. You see the same thing, and that is reflexive. And now guys, I'm going to say that triangle WMR is congruent to triangle RKW. And the whole reason I can say that is because I have one angle congruent, another angle congruent, and they share a side that is also congruent. That would be angle, angle, side. And remember what I said earlier, that your congruency statement, the W, has 2 lines. It has to correspond with the same angle with 2 lines, R up here with 2 lines. So W and R need to match. M, okay, M just has 1 line. Okay, so then it has to match with K, go in the same order as K. And then we move to R up here, and R of the green triangle has no lines, so we look on our pink triangle. W of the pink triangle has no lines or no arcs, no congruency markers, so it matches up with R. The order of these letters with triangle congruency is very important. All right, I'll be back with 4.4.